तो हेलो स्टूडेंट, दिस इज़ मी हेमंत सर और आज हम जेई एडवांस 2023 का और एक क्वेश्चन करेंगे. ठीक है, इट्स अ वेरी इजी क्वेश्चन बेस्ड ऑन solubility and solubility product. So let's see. The question is on decreasing the pH from 7 to 2. The solubility of sparingly soluble salt which is mx. So we are dealing with mx. ठीक है, it's a sparingly soluble salt जिसका pH जो है that is changing from 7 to 2. ठीक है, so obviously it's getting more and more acidic. Of a weak acid which is hx increased from 10 raised to minus 4 to 10 raised to minus 3 मोल पर लीटर. ठीक है, क्वेश्चन समझ लेते हैं अच्छे से एक बार दोबारा. ठीक है, सो देर इज़ अ sparingly soluble salt. ठीक है, whose pH is changing from 7 to 2. All right, ठीक है, the pH is decreasing from 7 to 2. At the same time, the solubility of this weak acid is increasing from 10 raised to minus 4 to 10 raised to minus 3. Getting me? Now all these changes in solubility is due to the change in pH obviously. ठीक है, now if we write the equation for, let's say, if we, okay, let's show mx will be dissociating something like this in m plus and x minus. All right, here we know at the beginning the solubility is 10 raised to minus 4. This will be also 10 raised to minus 4. Getting me? Right, now if I have to calculate the solubility product which is KSP, what I have to do? I have to multiply these two solubilities. So 10 raised to minus 4 and 10 raised to minus 4. So the KSP value which we'll get will be 10 raised to minus 8. All right, easy. Now what we have to consider, if we consider, let's say, for this weak acid HX, ठीक है, remember this value of KSP. all right, ठीक है. Now if we consider, let's say, HX, it will be dissociated as, of course, H plus and X minus. Now if we see, X minus is common in both, right? So the limited amount which will be left from this mx will be then surpassed to the dissociation or the formation of hx. ठीक है, ultimately actually we have to write it in this way. So I'll just write it as h plus plus hx minus will be getting hx. So this weak acid is actually forming. ठीक है, right? Now here the concentration of hx we don't know. All right, now if we say, let's say, if we show it something like this, we already know the KSP value. So for this, if we calculate the KSP value, KSP will be again solubility product of these two. So it will be hx and x minus. Solubility product value, KSP value, we know that is 10 raised to minus 8, right? For H plus, we know that the solubility has changed from 10 raised to minus 4 to 10 raised to minus 3. So this will become 10 raised to minus 3. And this X value we don't know. We know something from the mx dissociation of mx, the some value of some concentration of x minus, very of course limited amount will be come over here for the formation of hx, but we don't know how much. So for that we can calculate it somewhat like that. So here the x, the concentration of x will be, of course, it will become 10 raised to minus 5. Getting me? All right, so here we can justify that here H plus is, let's say, 10 raised to minus 2, hx is 10 raised to minus 5, and the total concentration will be 10 raised to minus 3 as it is given over here. Getting me? Okay. Now considering all those value, if we have to calculate, let's say Ka, so Ka will be how much? So we have gotten Hx as given. Okay. For x we have used minus 5, and from that we have calculated that it should be x raised to minus 2. Of course, very limiting amount, but as we know, the the solution is getting acidic, right? So there will be an amount of H plus over here, okay, which will be of course more than x minus and the total Hx concentration. Getting me? Coming towards the Ka value, so what do? Ka value के लिए we use the concentration of reactants. Reactant will be this, so we'll just 10 raised to minus 2, 10 raised to minus 5 from here, because these are the reactant, and the concentration of product, right? So it will be concentration of product, which will be 10 raised to minus 4. Ka will become 10 raised to minus 7 upon 10 raised to minus 4. Ultimately, we'll get Ka as 10 raised to minus 4. Getting me? And as we have got Ka value, from that we can use Pka value, which will of course become 4, right? So here the correct answer will be P4. So the Pka value for Hx will be 4. I hope you have understood. Starting off, we have started with the concentration of Mx, so it will be dissociating into M plus and X minus respectively, their respective concentration, and then we have calculated the Ksp value, which we have got 10 raised to 8 minus 8. Then with that Ksp value, we have considered the solubility products of H plus and Hx minus, which will ultimately form Hx, right? Getting me? From that we got the value of X, which will be 10 raised to minus 5. Now why this is very less? Because of course it has been dissociated from Mx, and there will be somewhat amount left, which will be then lead to the formation of Hx with H plus. So here we know that the amount of H plus will be on the higher side and X minus will be on the lower side. We can see that, right? Getting me? Now with the help of solubility products, we have calculated the concentration for H plus, which we got it as 10 raised to minus 2. Now with this all information, we have calculated the Ka value, which will be concentration of reactants upon concentration of product. We get that value as 10 raised to minus 4, and as we know the relationship between Ka and Pka, so we can conclude that the Pka value will be 4. I hope you have understood. Okay, it was a very small question, काफ़ी easy question था ये, ठीक है, बस the concept not even concept, it's pretty easy to understand. Just we have to consider the solubility and solubility product values correctly. Getting me? And by using those concepts, which it will be very much easy to solve these type of questions. I hope you have understood this question, and will come with more question and concept videos in the upcoming days. Thank you for watching, and yeah, take care. Bye bye.